the variance of x is equal to the expected value of x squared minus the expected value of x all squared. This is how to look for the variance. We also need to recall that our expected value of x is equal to np, and our expected value of x squared is equal to np plus n into n minus 1 p squared. Now, the next thing to do is to substitute what we have for our expected value of x and our expected value of x squared into the variance. It then means that our variance of x is equal to expected value of x squared is np plus n into n minus 1 p squared minus bracket np squared, which is also equal to np plus n into n minus 1 p squared minus n squared p squared. So this is what we get as our variance of x. So we have to resolve this mathematically. We come over to this side. So it then means that our variance of x, for more on this topic, you need to subscribe to this channel. Now, we have this will go into this and this. So we have n into n minus 1 p squared minus np, which is also equal to, we can open this bracket to give us n squared minus n into p squared minus np, which is equal to n squared p squared minus np squared minus np. Of course, this also can go into this. This is our variance of x. This is our variance of x. Our variance of x will now be equal to, this cancels this, so we have np minus np squared. So we have something that is common, which is equal to np into 1 minus p. We should recall that to say, but if p plus q is equal to 1, it implies that q is equal to 1 minus p. From probability, q is equal to 1 minus p. It then means that if we have 1 minus p here, 1 minus p, it then means the whole of this is q. So we can write it as our variance of x to be equal to np. We now substitute this q into here, npq. Hence, our variance of x is npq, That means our variance for the binomial distribution for the moment generating function is NPQ. Our expected value of x is NP, and our expected value of x squared is NP plus n into n minus 1 multiplied by p squared. So this is how we can obtain the expectation and the variance for the binomial distribution for a moment generating function. For more on this topic, you need to subscribe to this channel to get more tutorials on moment generating function.